So let's solve these two questions. They have been asked in NIMCET 2012. Let's start with this one. We have been given a number in hexadecimal number system because the base is 16, and we have been asked to find the equivalent value. Right? Now in the options we find that we have a number in base 10 and a number in base 2. So in order to solve this, the only approach probably would be to convert this hexadecimal number into binary as well as into decimal. So we'll take this hexadecimal number and convert it to binary and also convert it to decimal and then check with the options. So let's start by converting this hexadecimal number into decimal. Okay, so let's do this. So we have 2FA0C base 16, right? And now in order to convert this hexadecimal number system into, or hexadecimal number rather, in order to convert this hexadecimal number into a decimal number, we have to take the cumulative sum of the positional weights. So how do we do that? We start with C. I'm going from right to left, then it would be easier because the weights will be increasing from right to left. So C has a value of 12, right? Into 16 to the power of 0. Plus, this is anything multiplied by 0 will give me 0. So I'll directly write it as 0. Next we have A. A is given by 10 into 16 to the power of 2. Plus we have F. F is given by a value of 15. 15 into 16 to the power of 3. Plus finally we have 2 into 16 to the power of 4. Right? So if we calculate this, how much will we get? You can do the calculations, I guess. In order to speed things up, I'll use a calculator and I'll directly write the answer. See, such questions are nothing but a test of your calculation speed. The better you are with numbers, the faster you will be able to solve these questions, right? So I'll just write the values. First, we have 16 to the power of 0, that is 1. Anything raised to the power of 0 is 1. 12 into 1 will give me 12. This 0 can be ignored. Now we have 16 to the power of 2. What is 16 to the power of 2? 256. 256 multiplied by 10 will give me 2560. And then we have 16 to the power of 3, right? So 16 to the power of 3 will give us 4096, and that when multiplied by 15 will give us 61,440. That's quite a huge number, as you can see. And finally, the last value will be given as 16 to the power of 4, right? So that's 16 raised to the power of 4. So that is quite a large value. It is 65,536, and that when multiplied by 2 we get this huge number 131072, right? Now if I add up all these values, what would I get? 131072 plus 61440 plus 2560 plus 12. I'll get 195,084. And guess what? It matches with the first option. So we have a match here. So this and option A matches. So I cannot conclusively say that this is the correct answer because we have this option as well. It's definitely not option D because one of these values has been satisfied. So I have to check for the binary equivalent as well because we have this option with us, both A and B. Now let's quickly convert this hexadecimal number to binary. Now converting to binary would be a lot faster. Let's do this. So I would take each decimal, I would take each hexadecimal symbol or each hexadecimal digit and represent it using a 4-bit binary pattern. So I would take C and represent it using a 4-bit binary pattern. C in binary is 1100. 0 is 0000. A is 1010. F is 1111. And finally 2 is 0010. This is the binary equivalent, which can also be written as by ignoring these two zeros, right? The leading zeros, mind you, the leading zeros, these two, the leading zeros, these two leading zeros can be ignored. Leading zeros in a binary bit pattern have no meaning, so they can be ignored. So I can write this as 101111, and then again 1010, and then 0000, and then 1100. So this is my binary value. Does it match with this? Let's see. Okay, they have included the leading zeros as well. So if I check it with this value, if I check it with this value, is it matching? Have a look. See, I have 0010, then 1111. So far so good. Then I have 1010, and then I have 4 zeros, and then I have 110. Yes, it matches. So both A and B are correct. Right? Now moving on to the next question. The next question is telling us to find which of the following 4 options is used to supervise each instruction in CPU. Remember, when it comes to the task of supervising the unit or the functional module which is responsible for it is always the control unit. The control unit will generate control signals which will supervise or which will manage all the components and all tasks of a computer. What does an accumulator do? An accumulator is a special CPU register which is used as the destination point for all arithmetic and logical operations. What is the ALU? The ALU is the arithmetic and logic unit, which contains the necessary circuitry for carrying out arithmetic and logic operations. And what about a control register? Control register may sound similar to a control unit, but it is not. A control register is a processor register, mind you, which changes the general behavior of a CPU or any other digital device. So the correct answer in this case is control unit. Thank you.